All right, let me get set up here. Welcome. Today's lesson is on vocabulary. Vocabulary and math is really, really important. So there are two things that I'm going to ask you to do as you're taking these notes. The first thing is I want you to have different colored pens, maybe a highlighter. It'll help you to remember and it'll enhance your learning. The second thing that I want you to do that I'm going to ask is wait until I am done explaining the screen. Then you can pause your computer and then copy down the definitions, okay? Because you never know how long I'm going to go, how much writing there's going to be, so it might help you to wait. And also, you want to hear the definition and the description, and when you're writing and you're trying to listen at the same time, it just doesn't work well. So let's get started. The first word is integer. An integer are negative and positive whole numbers and zero. Here are some examples. We have ... -2, -1, 0, 1, 2, ... The ... dots in both directions are just the other negative whole numbers, -3, -4, -5, and positive whole numbers, 3, 4, 5, 6, 7. Okay? So why don't you pause the computer and copy those down. Our next word is opposite. Opposites are two numbers the same distance from zero on a number line. -2 and +2 would be examples of opposite numbers. -5 and +5 would be another pair of opposite numbers. Another way you could describe opposite numbers is the sum of opposite numbers is always 0. Sum being when you're adding numbers together. So when you add -5 and +5, you get 0. -2 and +2, you get 0. The third word is equivalent. Equivalent means equal to, and you can kind of see it here in the beginning of the word, EQUI. So equivalent and equal to. A question that could be asked is, what is equivalent to 6? Can you come up with any math problems in your head that would be equivalent to 6? I came up with 2. The first one is 5 + 1, because 5 + 1 equals 6. The second one would be 10 - 4, because 10 - 4 equals 6. The next word is an expression. Expression, we're going to have a little bit longer of a definition on expression. So again, why don't you wait till the bottom of the screen before you write this information down. It's a math phrase that uses variables, numbers, and operation symbols. Those symbols are addition, subtraction, multiplication, and division. The instructions when you're dealing with expressions will be to simplify or evaluate. And those instructions, they will ask you at different times, and you'll be doing different things. Expressions are broken into two types of expression. The first one is numerical expression. And if you've never heard the word numerical before, it means number. The second type is a variable expression. And if you haven't heard the word variable before, we're going to go over that in a little bit. So numerical expressions use numbers only. Numbers 7 + 7 would be a numerical expression. This would be a two-term numerical expression. 12 - 4 would be another numerical expression. Again, another two-term numerical expression. For our variable expressions, they are going to use numbers and variables. And variables are letters that represent unknown quantities. So 3x + 8 is what we call a two-term variable expression. 4b times the quantity of 16 + 2, this would also be a variable expression, and the letter b here is our variable. Okay, and this actually is going to only be one term, as crazy as it sounds, but we'll get more into that in a little bit. So we're going to do a little bit of practice right now. It says identify each expression below as a variable or numerical. So why don't you pause your computer and look at these 5, write them down, and figure out if you can identify whether they are variable or numerical. And then, if they are variable, what is the variable? Okay, now that you're back, 4x + 7 is a variable expression. It's actually a two-term variable expression, and x is our variable. The second example, 3 - 8, would be a numerical expression. This again is a two-term numerical expression. In the third one, 4 times 5 plus 5 would be another numerical expression. And again, this would be a two-term expression. The fourth one, 5n plus 15, this would be a variable expression, the variable being n, and this would also be a two-term expression. The last one, 18 plus 15, would be a numerical expression, and again, this would be a two-term numerical expression. We're going to describe what terms are in a moment. Right now, as a matter of fact. So a term is a number or variable, or the product of numbers or variables. Terms usually are separated by an addition or subtraction sign. So we have an expression here, 3x plus 8. So 3x plus 8 is a two-term expression. The first term is 3x. The second term is plus 8. And again, the first term and the second term are separated by an addition sign. The word variable is a letter in an expression that represents an unknown amount. So we're going to use this expression, 3x plus 8, for the next three words. So the x is our variable because that's the letter. Our coefficient. Coefficient is a number that multiplies or is attached to a variable. In the example 3x plus 8, the 3 is being multiplied by the x, so that is the coefficient. And if you think about it, the word co-worker, coefficient, co means together. So it is together with the variable. And then the last part of this is constant. It's a number in an expression. So in our expression 3x plus 8, the plus 8 is our constant. Again, let's pause our computer. And what I'd like you to do, you have three different expressions here. I want you to identify the variable, the coefficient, and the constant in each of these three examples. Okay? Okay, now that we are back, 4x plus 7, the variable is the letter, so it should be x. The coefficient works with the variable, it should be 4, and the constant is the number, it should be 7, positive 7, and I'm just going to write 7 because it's assumed it's positive. In the second example, they're mixed around a little bit. Our variable is m. The coefficient, the one working with the variable, would be positive 10. And then our constant over here would be negative 8. For the last example, our variable is c. The coefficient working with the variable is positive 4. And the constant is positive 15. I hope you got those right. And it's good just to understand these. And the last one we're going to do, the last part, is identify the two-term expression that has a constant of negative 4, a coefficient of 5, and a variable of x. Why don't you pause your computer right now and try and figure out what that answer is. Okay, now that you've taken your time and you've paused, our coefficient is 5, our variable is x, so it's going to be 5x, so it's either b or d, and our constant of negative 4, so that means that it has to be b. I hope you understood that. That's our definitions and that's our vocabulary, and we're going to be using those for the future, and you're going to be using these for the rest of your math career. So the quicker you learn them, the more successful you're going to be. Go back and watch this video, listen to my words, try and mimic what I'm saying, and that'll really be helpful. Have a great day.